Describing data, frequency tables, frequency distribution, and graphic presentations. Wisconsin, let's get you on here. We good?
We're good.
We're good. All right, so now that we understand variables and levels of measurement, we understand all the data. We're looking at the inputs that we have available to us. And remember, our choice is going to be based off of what it is that we're trying to tell. What story are we trying to tell? Now, I often say that a good picture can replace 1,000 words. We've all heard that. That could never be more true than in statistics. So what we're going to talk about are some ways that we can display this data in a meaningful way. A frequency table. A group of qualitative data into mutually exclusive and collectively exhaustive classes showing a number of observations. Can anyone tell me mutually exclusive and collectively exhaustive, what that means? Because I will tell you, economists, we love that term. We love those two terms. Mutually exclusive.
Both things are completely separate, and when you put those two things together, you have covered all of your bases.
Absolutely, good job. It means that collectively exhaustive, there were 180 cars sold. And if Kane location sold a car, Sheffield could not have sold that same car. So you are either, if you're in one of these locations, you are not in the other. And collectively, all of these locations equal total number of cars sold. So a frequency table, a group of qualitative data into mutually exclusive and collectively exhaustive classes, showing the number of observations in each class. Pretty simple? You got it? Yeah. A bar chart. Now, as I show you this, how is your comfort level with creating a bar chart inside Microsoft Excel?
Pretty good. I'm pretty good at that.
Okay. So a bar chart, a graph that shows qualitative classes on the horizontal axis and the class frequency on the vertical axis. Class frequencies are proportional to the heights of the bars. So let's see here. Kane had 52 cars sold. Here's Kane. Notice we just breached the 50 vehicles sold line on the vertical axis. Sheffield, let's find Olean, 40 cars. Notice Olean's height corresponds to 40. The pie chart shows the proportion or percent that each class represented. I like to say a pie chart shows everything's relationship to the whole. Going back to geometry, what percent is covered inside this circle?
100%.
100%. So when I start to carve it out, I can identify SUV 50% of the whole.
Isn't the SUV 30%?
Are you looking here?
Yeah.
You're looking
The
here.
number sold was 54 and the percent sold is 30.
Sedan 25. Does our pie chart not match up to?
The 50% is at the halfway point. Like that little tick mark shows the 50%.
It's at the halfway tick around here.
Maybe I'm just confusing myself.
No, I see what you're saying. Here's their 0%. Here, think of the clock.
Right.
Here at the 3 is the 25%.
Now they're at the halfway mark.
At the 6 is at 50. At the 9 is 75. Okay, I see what it's showing here.
So if you're looking at that pie chart, are they kind of tracking two different types of data, basically?
At this pie chart, the question is, are they tracking two different types of data? I would argue that they are giving numerical, they're giving quantitative measurements of the, Lord, I'm going to get into a geometry lesson here, but they are giving quantitative description of the circumference of this circle.
Okay.
They're using colors to identify what relationship. So here, SUV is going to be approximately 30% of this total circumference is going to be shaded in with SUV. Thank you for clarifying. Now, a good example of a bar chart. Ski Lodge is test marketing a new website, interested in how easily its website design is to navigate. It's randomly going to select 200 regular internet users. Why would we randomly select 200? We will answer that question in time. Time will tell. But that gives you something to ponder on. Why do we randomly select? But they randomly select 200 regular internet users and ask them to perform a search task on the website. Each person was asked to rate the ease of navigation as poor, good, excellent, or awesome. And here are the results that are shown. What type of measurement scale is used for ease of navigation? All right, draw a bar chart for the survey results. So here would be our bar chart. Again, the height of each, identifying with the relative frequency of each. And then over here, we're drawing a pie chart. And in this case, they are not tracking the circumference of the circle. 51% is the relative frequency, and 51% corresponds with the awesome rating. Real quick, everybody said you felt comfortable doing the bar chart in Excel. How about a pie chart?
Yes.
Okay. In this slide, it's going to walk you through. I would say if you are presenting, one thing that I point out is it's usually a good idea to give these slices labels. Again, when I look at that picture, I should be able to pull out a lot of the most amount of information. And if I want to do that, I shouldn't have to look back over here and say, okay, blue, see, that's roughly 60% of the circumference. What is 60%? Oh, prizes. I should be able to just look right there. So be sure when you draw your pie charts that you give each category a label. A frequency distribution. A group of quantitative data into mutually exclusive and collectively exhaustive classes, showing the number of observation in each class. Okay, here what I'm replacing it with is the term class. So profits from one class would be the profit of $200 up to $600. And we are going to count the frequency that falls within that range. And then 600 to 1,000, count the frequency within that range. So again, the class is going to represent this range. How do we determine how wide that range should be? All right, let's identify some terms and I'll answer that question. Okay, the class interval. Is obtained by subtracting the lower limit of a class from the next limit of the next class. Okay, so once I get this range, I know that I'm going to keep my interval is $400. So I'm going to repeat $400 throughout. The class frequency is the number of observations over here. And the midpoint is if I divide the class into two equal parts, where is my midpoint? So the midpoint between $200 and $600 we'll call $400. Now let's look at an example of creating a frequency distribution. Okay, if you will refer to your text, okay, we're going to start at the bottom of page 25 and go to the top of 26. Now, Applewood Auto Group is going to be presented throughout this text. Applewood Auto Group wants to describe the data collected on the profits for the 180 vehicles sold last month at the 4 locations. Mrs. Ball would like to know, 1, what is the typical profit for the 180 vehicles sold? 2, what's the largest? 3, what is the lowest profit on any sale? And number 4, what is the typical value of profit, or around what value of profit do we tend to cluster? Why would she want to know these things?
Pricing adjustments.
Pricing adjustments, obtaining goals. I'm sure that they have budgeted an expected amount of revenue, an expected amount of profit. I always put this plug in. What's the goal of every corporation?
Make money.
If we make money, that's illegal. The goal of every corporation is to maximize profits. Any class you take with me, you'll hear that. The goal of every corporation is to maximize profit. So if we are going to maximize profit, pricing becomes important. What vehicles do we want to sell? Because where are we earning the highest profit? Okay, so step 1 is we've got to decide on the number of classes. Now, if it's helpful to you, flip back from this presentation, but this is an example of the textbook where I said it gives you an excellent example of how to solve the problem. But if you'll walk through this and flip back to a description of the frequency distribution. If not, I'm going to show you one on the next slide. So here, how many classes do I need? Okay, so what we're going to do is we're going to solve using K. We're going to solve here. 2 to the K rule. So we're going to say that the number 2 raised to the K power is greater than N. N is going to represent the number. In this case, in statistics, and in most, well, I'm going to say statistics. In statistics, when we use the word N, we are referring to the number of items we're working with. So in this case, we're substituting it from the population of this auto group. So 180 vehicles were sold, so N will equal 180. So look how we apply 2 to the K rule. All right, if we use 7 classes, 2 raised to the 7th power is 128. That's going to be less than 180. If we go to 8, 2 to the 8th rule, or excuse me, 2 to the 8th power is 256, which is greater than 180. So you would choose 8 classes. Applying this rule, you would keep raising the number until your value exceeds the value you've assigned for N. Wisconsin, do you have that?
Yes.
Okay. And once you have decided on the number of classes, next, how are we going to decide on the interval width? All right, so the interval width is going to be equal to or greater than. H is going to designate the highest observed value. L is the lowest observed value. And remember, K here, you just solved. So in looking at your raw data, and this can be found on the textbook on page 26, we see that a high value is $3,292. The low profit is what?
294.
294. And we are going to divide that by 8. Again, 8 for our number of classes. Now, once you arrive at this, notice our output, $374.75. Go ahead and round that up to some convenient number, some relevant number, such as a multiple of 10 or 100. If I were this close to 400, I would go ahead and round it up to 400. You know, if I was at $301, you might round it, you might not take it all the way up to 400, you might cap it off at 350. This is going to be at your discretion, but I would see that whatever you calculated here, somewhere you better round up no more than to the multiple of 100. Wisconsin, are you with me?
Yes.
Now, step 3, set up the individual class limits. So we just identified we were going to have 8 classes, 1, 2, 3, 4, 5, 6, 7, 8. And we said that our class width would be $400. After you've done that, you're simply going to count or tally vehicle profits that fall into each class. And step 5, count the number of items in each class. All right, now if I were doing this real quick, you know, if I could get this data into Excel, if I was using a large set of data, I would get it into Excel. I would sort this. from high to low. It's going to quickly identify. In this example, we have not even half a page of a book. It's kind of easy to look and pinpoint. But again, if you were just downloading raw data, you would have to arrange that in some order, again, to make it easier for you to work with. So you would use the functions like a count to count how many cells or how much data you had in there, how many items you had. You could also use it for sorting high to low. All right, 3 other items that we use in graphical form would be a histogram, frequency polygons, and cumulative frequency distributions. All right, we are out of time. Any questions, Wisconsin? Are we still smiling?
Not currently.
Not currently, no questions or not currently smiling?
No questions.
There's those smiles, there's those smiles. Okay. With that said, we'll be signing off.